Hi, my name's Kevin Mack, and recently we've been onboarding a lot of developers, and we use Git for keeping control of all the code, the check-in, and versioning. So one of the things I realized is there's a lot of confusion about Git, and I put together this presentation probably about 5 years ago with Eric Katz, and recently looked at it and think it's a good oversight or overview on Git, and it's a great way to have a base understanding of what Git is and how you can apply it to your projects. So this isn't going to be, this is a little bit more on a presentation wise than some of my other videos, and what I'm going to cover is what is Git, really how to install it, some project setups for it, so different flows that happen with Git, the approaches and best practices for using Git, and then in a later video I'm actually going to be recording a live demo. So this is similar to like the BEM video. I started with a live demo and then did a presentation. Kind of doing the reverse on this one, where I'm doing a presentation first and then I'll be doing a live demo. I'll probably actually do that one as a true live demo, so through a YouTube live. I'm here with Vitaly too, but he's off to the side. So if you hear me talking to someone, I'm not insane. I'm talking to Vitaly. And I'm also not really, I haven't really looked at myself, so I don't know what I look like today. And I'm just wearing an undershirt, and I'm realizing that right now. I didn't really prepare for this, but yeah, I'm just kind of winging all this too. So anyways, we'll get started. So this is the classic way to start off any presentation, with a dumb joke. So if you do a Google search for Git, this is what actually comes up. I don't know why that comes up. It's really stupid, but that's what actually comes up when you do a Git. But Git is actually a repository hosting service. So it's not GitHub. So that's one of the first things that I always mishear when people are talking about Git. They're like, let's start up a GitHub. But GitHub is its own is a repository hosting service. So it's its own product. It was recently acquired by Microsoft. Git is the actual product or the technology that runs GitHub. So that's the first thing. Git is a version control system for software development, simply put. The big thing is that it's about snapshots, and it's really not about differences. So Git is looking at your technology and the product that you're building as snapshots, and not really comparing to anything else, but it's looking at it in a time frame. So as I said just said, snapshots, not differences. And then with Git, what you're actually working on is the local environment. So when you're working with Git, you're working on your code on your local machine, and then you're pushing it up to a remote area where other developers and other people on your team can access it. But everything's really happening locally, and in this presentation we'll talk about what branches are and how to go through that process and how a team kind of works and collaborates together. With that, Git is only adding data, so it's not really storing anything. Everything is stored as data pieces. The really cool thing compared to other repository systems are, as you move from one branch to another, if you check out a branch that maybe had a directory full of images, and then another branch that doesn't have that images, it actually removes those files from your local system, but those files and that data still exist inside the repository. So it's this really cool way of doing it, where there's other repository systems where it keeps those folders or those directories on your machine, but then when you go check it out, check out another branch, you still see that data there. So that's what a cool thing about data is. It's really that snapshot of wherever that code was. And when it comes to Git, this is really what's important, is there's 3 states. So there's really maybe a fourth one, but it's committed, modified, and staged. So when you have a file in your system, there's what you have to do is we'll go through the process of adding it, and then you commit it out there. And then if a file lives inside of the Git repository, it will then be able to track the modifications for it. And then once it's actually staged, means it's getting pushed up. There are a lot of benefits when it comes to Git, but these are probably my 4 favorite. It's to, number 1, first increase collaboration between a development team. So before Git, I feel like it was very hard for myself and someone else to be working on the same project at the same time. And due to Git, it allows us to be working almost, we can even be working on the same file at the same time and be working on separate machines and still not having a lot of conflict if you're following the process right. The second is it improves experimental development, meaning that I can create a snapshot of my code, branch it out, and start working on something that could be a future release. And doing it that way, I'm not muddying up the development process. So I can be working on things that are maybe a release or two out without getting it inside of this current release or maybe my production release. This kind of goes without saying, it's related to the first one, but you can work on your own while contributing to the project. So depending on like your project process that you may have, you may be using like Agile, and you may have taken a card and you're working on it, and you're working on your own sub modules. Modules are pieces of code, and you can contribute that separate to what everyone else is doing. So you can be working in your own space, but still contributing to the project. And this last one is more of a joke from where I previously did this. It's better than TFS, which is Team Foundation Services, which is the Microsoft. And this was actually, when I did this presentation, TFS was, or Git was not included inside of Visual Studio, and Microsoft, I guess, products for development did not play well with Git, and then they only worked well with TFS. But then TFS, and the ironic thing is now Microsoft bought GitHub, and now everything's in Git. But my big warning about Visual Studio and Git is there's this button called sync, and you should never use that. You should be really just using the command line or a Git GUI of some sort. Anyways. Installing Git, it's actually a pretty easy setup to do. If you're on a Mac, it should only take you a few minutes. If you're on a Windows machine, there's one additional step. You just have to add it to your path. But if you're a developer, that's probably something that you're used to doing in one way or another. But first you download it. It's free. It's open source. And it's Google search away from you. That's basically all you have to do is Google download Git. If you're on Windows, as I said, you add it to your path, and then you set up an SSH key. And then from there, you can start working on your project. So an SSH key, and this isn't just in Git, but anything that you want a secure connection between yourself and a remote, I guess, code base or remote anything, you create up an SSH key, which allows you to have this handshake from your computer and maybe an external server so they can communicate back and forth. So it's just a way to identify that your computer's trusted, and you don't necessarily need to put a password. So how it works is you generate an SSH key on your machine. If you're using GitHub, Bitbucket, or whatever your repository hosting system is, you then can add that SSH key, which is this private key that then that hosting platform knows that this is your computer and this is your login. It's just an added layer of security. But what it allows you to do is then to push your code back and forth from the Git repository, from your local machine to the remote one, and to make sure that nothing gets in between. So definitely recommend doing an SSH key when doing Git. It's not a requirement, but if you're not doing that, then you have to log into your Git repo every single time, or your Git service host every single time. And proper way of doing Git is more like micro commits and pushing out to your team as frequently as possible. So it's not like other repository systems where you wait like 3 days and then you push it out to everyone. With Git, you should be doing it with you finish a little piece of it. It's in a tested. It's in a solid space. You commit it and push it out there. So with that, it definitely saves you time and adds security. Looking at a traditional project setup. So this is the next section here in this little presentation. So the first one is when you're creating a project. The first time you do it, you have to do what's referred to as a git init. So you init it in saying like, I want this folder on my local machine to be a Git repository. So it initializes Git. From there, you go to your hosting platform, or your hosting provider. So you go to your GitHub, your Bitbucket, your Microsoft service of some sort, or whatever you may be using, and then you create the repository on site of either, we'll just say GitHub. From there, you add that remote to your local machine, which then becomes the handshake from your local machine to the remote, which would be GitHub in this example. It's heavily recommended that you create a git ignore, which allows you to prevent things from actually committing from your local machine. And then once you are starting to code, you add files, you commit them, and push them. And that's going to be the process, this 4, 5, 6, that happens throughout the development cycle. So again, I'm just going to go through these tiles again. Init happens really one time on a project. It's where you create an empty repository on your local machine. You add a remote. You can actually add multiple remotes on a repository, which is really cool. So maybe you wanted it in GitHub and you also wanted it in Bitbucket, or you want it in your personal repository and also your company's repository, because maybe you like to steal code from the company you work at. It happens, Vitaly. From there, it's just associating your local to the remote. And that's also then, this remote is where other developers are going to be. So here you are in your machine, and then here's the repository, and here's some other developers working on it. And that becomes like the pivot point for all the code. The git ignore, as I said, is so you stop tracking files that you don't want. It can also be directories and folders. Adding is one of the most important pieces. So this is actually when you get into the development part of the project. So you add files. So what that means is I create a file, I add it. By adding it, it means that can now be added to my repository. For some reason, when you say that out loud, it sounds really easy, but a lot of people get confused by it. So it's just saying like initialize this file to be a part of this repository. So we're adding it to the repository from my local machine. A commit is the most common piece of Git. A commit is where you're actually creating that snapshot that I was talking about earlier. It is a message, and it describes the work that you were just doing. There's some different methodologies and beliefs on how to write a commit. Some people are like hardcore, like crazies about how to write a commit. For the most part, I'm too busy and I have too many projects going on to actually argue about that one. But I do argue about almost every single thing in development, maybe besides the format for writing a commit. But basically what it is, you add the code and then you're writing a description of what you just completed. And then on a project, if you have multiple people on it, it's just really best practices is you're taking that local code, you've added it on your local machine, you've made a commit locally on your machine. You want to check to see if anyone else on the project has committed anything. So again, you're here, and then you have your repository, and you have other developers that are contributing to that repository, and it's coming back down to you. So how you're bringing in the code from these developers over here to your machine is you do a pull from the remote. So from pulling from the remote, it's going to bring in the latest code from the repository. And then that's how you're lining your code from other developers. And Vitaly, if you have any questions as I'm doing this, you can be the voice of reason if I'm talking chaotic.
Okay.
So a push then is where you're taking your code from your local machine that you've already brought in external code, and you're pushing it out so then everyone can access it. So similar to like what I was saying on the last one, where there's these developers going to the repository and you're pulling it in. A push is when you're, instead of pulling it, you're pushing it out, and then other developers then can access that code that you have. So that's an important piece.
You said like pull after you commit locally on your machine?
Yeah, so after you commit, you pull. And what that does is you've added the files, and then you're going to align it to whatever's out there. You can't actually do a pull before you do a commit. It's going to cause, if it allows you to do it, it's going to cause a kind of more of a chaotic development environment for you. And if there is a conflict or something that you need to merge, you can't easily roll back. So you can always go back to any snapshot or commit that you have. So that's why it's better to commit and then pull in the external code.
Okay, that makes sense.
Does that make sense? Okay. And then a push is just pushing it out there to the repository. So in an existing project, this is the typical workflow. So I created the project already. I already did the git init. I've already pushed it out to GitHub or Bitbucket. And I say, hey, Vitaly, the repository is ready. What he will do is clone it. So he'll do a git clone. And then that code from the repository is now accessible on his local machine. And he can start working on it. So first is he can either use the existing branch that pulls down So we'll talk about the process and the flows of GitFlow, but you can create what's referred to as a branch where you can be working on your own code separated out. So that was one of the, I think the number 3 thing was like you work on your own stuff. Ideally, when you're doing development, you're working with a team, you're always branching on your own work. So after you get past step 2, you're either on the default checkout and you're on the branch that's default in the repository, or you're making your own branch. But then you get into number 3 where you code and you do whatever it is. From there, after you code, you're going to add your files. So adding exists for new files, but it's also what you do for existing files or modified files. So that's also really important to know. Adding is any modified file, not just a new file. When you're done adding them, you commit. You can add all the files all at once, or you can add an individual file. So say I was updating 10 files at once, and I then updated my git ignore. Instead of adding all of them, I could just say git add.gitignore, and then from there do a commit that just says updated gitignore to hide the DS store files on Mac. From there, I still have my other files, and they're not included in that commit or that snapshot. The only thing that's out there is the update to the Git file and nothing else. Now, once I'm ready and stabilized with the rest of them, I could then add the other files and then add a commit that's related to them. So the commit should be related to the files that have been updated and the feature or function that you're actually building. Early in a project, you may have like more bulk commits and pushing them out, but ideally the commits are aligned directly to the files. And if someone were to pull that snapshot or that commit down at any time, that they should be able to run the code properly. And then from there, you commit the code, you pull, and then you push. That's the same thing that keeps happening, that add, commit, pull, and push. So again, a clone is you're tracking the remote branch, but you're bringing it locally on your machine. So you're bringing the remote, actually repository. And then from there, you can fetch all these different branches that are out there. And this is a definition that actually works really well for Git. It's to think about the project that you have. So the repository is maybe like the trunk or the tree. And then the branches are the pieces that are going out and flying out. But a branch is actually the technical term in Git. So it's like you're taking the code base that's going here, and you want to branch out and work on something. And then eventually you want to bring that branch back into the actual project. So branching out is just taking a snapshot of the overall project, pulling out something, and it can go back completely linear. So you can go back to the first commit, branch out there, or you can branch out of commit like 5,000 and then kind of roll it back if you want to. But basically what a branch is the code base, and you're pulling it out to work on a feature or set or something for it. A checkout, so when you hear the word checkout, what it is you're switching branches and you're going from one to another. So I'm going from the feature slash update promotions to develop branch. So I check out those branches. So that's the what you're actually writing command line, and that's the lingo of when you're talking about Git. So again, on a project, the basic thing is you're checking out a branch, you're coding, you're adding, you're committing, you're pulling, and pushing. For a basic project, this is where you're going to actually be living in the most, is actually that branching, pulling, and then once you pull, you're going to be doing what's referred to as a merge, and then a additional coding. So from here, what you do in Git is you're working on a project, you already have it, you already have your branch, and you can pull from the remote system to bring in the most recent code. But if I'm working on a feature set that isn't ready to be deployed yet, I may have some conflicts that happen, or my code may be too far ahead or too advanced. And to resolve those issues, I have to do a merge. And the process that I'll talk about, or the methodology GitFlow, will help you resolve any issues with it. But basically, I'm working on feature slash add promotion. From there, say that piece of work is actually a 2-week timeline for me to complete that. But the develop branch, where all the other developers are working on, have been committing code daily or hourly or every minute. my code is going to start getting behind from the develop branch. I can actually push out my feature add promo to the repository so anyone can access it, but it's not actually in the develop branch yet. It is in its own branch separately as its own snapshot. Once I'm ready, I can decide when I want to pull in develop. Because maybe there was a feature contact us page, and we want to have the contact us page to have offers that I'm working on. Well, I would want to pull in that block of code without messing up mine. So how I would do that is I would pull in and merge that branch into my code base and then align it. And once I'm ready, I can push it out and talk to my team about when we want to merge it into the branch that everyone's working from. So merge is just combining two branches together to make one. And the idea here is to also let your team know when branches are being made. And a lot of times, like in projects, we have gatekeepers. So there's a core branch that everyone's working from, and that's the source of truth. And then everyone's working on their own branches and then merging them into that once the team says we're ready to merge it in. Typically, there's a review process there. So that's what's referred to as a pull request in GitHub. You create a pull request, someone reviews it. If it's ready, it's merged into the main code base. And then from there, if that becomes the source of truth that other people start pulling in. Big thing with Git is, as a process, you have to collaborate and communicate as a team. You can't just be off on your own island. So Git adds resolves a lot of headaches when it comes to version control and managing your code base. But you still need to communicate and collaborate as a team for it to be successful. If you look at some of the most popular open source projects that are all run on Git, you can see that there's long conversations that are in the issues sections and any of the Slack channels for some of those open source projects. So people are still communicating. It's just a piece of the process. It doesn't replace the process of communicating or collaborating. And then this section here is to really talk about GitFlow. And this is what is really a changer in the way of looking at Git. And this was actually created by the creators of Git as a way that Git was always supposed to be used. So it's not really a methodology that was created by the community. It's been adopted by it. And it's not really to say set in stone that you have to use GitFlow, but it's definitely a recommended approach. And it helps you overcome some of the issues that you may have with Git. So I don't remember what this first thing says here, but all right. So it's a common pattern for managing feature development, releases, and maintenance. So it's just really a way for you to organize and making sure that you're creating scalable projects that can easily maintain, and you can pull out and edit any single time. But as a team, you know where pieces and parts of the code are and where the source of truth is from a code base. It has 4 main pieces for it, and the first one is master, second is develop, the third is a feature or feature branches, and the fourth is releases. So master is, you can think of it as the source of truth of something on production, and development is the source of truth for the next release that you have. Features are things that developers are working on at the time. You can have as many features and branches as possible. The idea is that they're temporary. They get merged into your development branch, and then development branch eventually gets merged into master once that's ready to go to production. And then once it's in production, your master branch actually becomes the release branch. So it becomes a way for you to track versions inside your code base. Typically, people follow the release branch under semantic versioning control, so like v1.major.minor.hotfix. So master branch is the official release history, and it aligns to what's on production right now. So if someone in the code base was like, your project manager comes up to you or a client comes up to you and they're like, their hair's on fire because there's a production error. And say we're already working on the next release in development. Well, we know that production error is, or we know the error's on production. So what we can do is look at the last release, which was our master branch. We can then branch out from the master branch, resolve that issue, and then from there, push it back out. And then master branch gets merged into our development and then also becomes a release. But master branch is what's on production right now. And in that case, by working on master and pulling it aside, creating its own branch, updating it, testing it, pushing it out, I haven't brought in any of my future release or development stuff. It's been separated out from the actual code base itself. So it's a way to know what's on production and what you're actually updating without releasing maybe a feature or function too early on. The development branch is really that source of truth of the next release. So always think of it as you're aiming for the next release that's going to go into master. And what this is where development teams are working on pieces, and what they're working on are features and releases. And it is supposed to be completely stable. So master is supposed to be stable. Development branch is supposed to be stable. And by stable, I mean that there shouldn't be like run errors on it. Shouldn't have anything experimental in it. It should be really the next release, and it should be tested. As a team, I recommend always having a gatekeeper or someone doing review on master, and I highly recommend having a gatekeeper on development. And that gatekeeper is someone that is, even if it's two developers of the same experience level, just having another source of eyes reviewing the code before it gets pushed out there. A feature branch is literally written in Git as feature / whatever you're working on. And different teams I work on in different projects, sometimes we namespace with initials so they know who it is, but they're meant to be temporary, or you would never release from a feature branch. This is just the current code that you're working on. They're meant to be merged into the development branch once they're ready. And for these, they can be smaller features like hot fixes, like a bug fix that we have that's on production. They can be something that's a month-long feature. You can actually be merging one feature branch into another feature branch. So Vitaly's working on something that's maybe a month long, but then I have a little piece that I got done. We can be communicating back and forth and making his be the source of truth for that feature. But once we're both ready, the code can be merged into development. So it becomes a way for us to manage and maintain the features that are going without having conflict between two developers. And then the code that's on development is going to be stable. Making sense?
Yep.
This is boring?
No.
Cool. And then, as I said, the release branch is dedicated to the release. Why these are important is as much as you may test and as smooth as you may think you are as a team, there's always going to be a time where you're like, we need to roll back. And as an external development team that's, running an agency, working at consulting firms, being a part of the agency world, there's many times where we release something because we got the green light from a product owner, but then one of the executive team members are like, why is this live? Not only is that like the most stressful thing, if you don't have a way to go back to a previous release really easily, then you could be wasting a lot of time and effort to do it. So release branches are named as release / whatever that v1.0.20 may be, so following semantic versioning conventions. But really, it's just a way to easily roll back. With Git, you can always see in the commit, it is a snapshot of history, so if you weren't using release branches, you could always find where that commit was for that production release in master or in your development branch. This is just an easy way to keep track of future or previous releases. And it becomes really nice, say, if you do a major redesign, so you go from like your V1 to V2. If you ever want to run the old version of your site locally and show it off, it's really nice to do. But these are things that are from master and have actually been pushed out to production. So with that, this is where I want to get into a live demo, but I want to keep this video kind of short, and live demo is probably a little bit more on having a real life example. I tried to mimic it before and it doesn't work that well. So I'm going to probably have a follow-up video where we're actually doing command line in Git as well as using a GUI for Git. And for GUIs on Git, if you want a free one, Source Tree is really fantastic. That works on both OS X as well as Windows. If you're on a Windows machine, hands down the best is Tower. And then if you're only working in GitHub, you can use the GitHub tool, but it's a little bit limiting, and that's really meant like 101 type of getting used to getting your feet wet with Git. It doesn't give you the full snapshot of what Git actually can do. So if I was to rank them from an OS X side, I would say the GitHub one is at the bottom, and then Source Tree, and then Tower. But if you're get familiar with Git, I would highly recommend just learning command line and going from there. So that's basically all I have for this. Vitaly, do you have any questions before I end this video?
Not that I can think of.
Cool. Well, with this and like other videos, if you have questions, comments, leave them in the comments section. You can hit me up on Twitter. I'm Nicetransition, and I try to be as quick as possible to respond. If there's something in this that was unclear, I can do another video just on that topic, or spin off something, or try to explain it in one way or another. So don't hesitate to reach out. Let me know how I can help out. And I hope this was helpful for at least getting a base understanding of Git. So thank you.